So let us discuss a common integral packet problem, which is find the indefinite integral of sine to the sixth power of x times cosine of the fourth power of x dx. In order to reduce the complexity, we could try to simplify this using some decomposition and a couple of trigonometric identity. First, anything to sixth power is square of it times the fourth power of it times cosine of the fourth power, which we already have, dx. Now, using property of exponent, we can rewrite this as sine squared x, parenthesis sine of x, cosine of the x to the fourth dx. Why did we do this? Well, because the double angle formula says sine of 2x equals to 2 times sine x cosine x. So this quantity here, sine x cosine x, should be half of sine 2x. Using the substitution, we can rewrite this as integral of sine squared x, parenthesis 2 underneath sine of 2x to the fourth power dx. So we get the 1/2 to the fourth power out. So 2 to the fourth power is 16. So this is equal to 1/16 integral sine squared x sine of fourth power to the 2x dx. And we have to now use power reduction formula to deal with these square terms. So power reduction formula says sine squared of 2x is equal to 1 plus cosine of 2, not 1 plus, 1 minus. 1 minus cosine of 2x over 2. Now, by similar reasoning, sine squared of 2x should be equal to 1 minus cosine of 4x over 2. We have sine to the fourth, so sine to the fourth of 2x, which is equal to sine squared of 2x to the square. So that should be equal to 2 underneath 1 minus cosine of 4x squared, which is equal to 4 underneath 1 minus 2 times cosine of 4x plus cosine squared of 4x. Now, we see that we have another square term of a trigonometric function. So we again have to use a power reduction formula on that. So cosine squared of 4x equals to 2 underneath 1 plus cosine of 2x. So this sine to the fourth power term can be rewritten as 1/4 parenthesis 1 minus 2 times cosine of 4x plus 1/2 plus half of cosine, wait, that's the 8x. 8x. And then if you factor out a 2, what we get is 1/8, 2 minus 2 cosine 4x plus 1 plus cosine of 8x, which is equal to 1/8, 3 minus 2 cosine 4x plus cosine of 8x. Let us combine all these things that we have. We have to first remember that we have a 1/8 that needs to be merged with this. And not only that, we have 1/2 that needs to be merged with this. So 2 times 8 is 16, and 16 times 16 is 256. So you can rewrite this as 1/256 integral of 1 minus cosine 2x, parenthesis close, and then another parenthesis, and then 3 minus 2 times cosine of 4x plus cosine of 8x. Oh, wait, that's a 4. So, sorry about this. That should have been a 4 there. Wait, that's 2. And what I mean is that is 4 because of this 2. So that's 4. So that one is 4 plus cosine of 8x and then dx. All right. Now what we have to do is we have to FOIL out everything. So if you FOIL out everything, what we have is 1 over 256 integral of parenthesis 3 minus 3 times cosine 2x. And then we have not plus minus 4 times cosine 4x, and then minus minus gives us plus 4 times cosine of 4x cosine of 2x. And then we have plus cosine of 8x, and finally minus cosine of 8x cosine of 2x and dx. So what should we do about these situations? We can use product to the sum formula for this. So using product to sum formula, we can say 4 times cosine 4x cosine 2x term is equal to 2 times cosine 4x minus 2x plus, I need a parenthesis here, cosine of 4x plus 2x, which gives you 2 times cosine 2x plus 2 times cosine of 6x. Similarly, cosine of 8x times cosine of 2x equals to 1/2 cosine of 6x plus cosine of 10x. We have this pesky half, so we can actually take care of, well, let's first substitute this and this into the respective places, and then see what we get. We have 1 over 256 integral of 3 minus 3 times cosine 2x minus 4 times cosine 4x, and then we have plus 2 times cosine 2x plus 2 times cosine 6x plus cosine 8x, and then we have minus half of cosine 6x and minus half of cosine 10x dx. Let us take out the factor of half. When we do that, we have this whole expression equals to 1 over 512 integral parenthesis 6 minus 6 times cosine 2x minus 8 times cosine 4x plus 4 times cosine 2x. Well, actually, why not let us combine like terms before we calculate that? Yeah, so let us first combine like terms, because we have minus 3 and the 2 here, so we have minus cosine, the minus doesn't look good, so minus cosine 2x, and then we just have a minus 4 times cosine 4x, and then we have 2 with the minus half, which give us plus 3 over 2 cosine 6x plus cosine 8x minus 1/2 cosine of 10x dx. Let us, start calculating the antiderivatives because, we're ready. So when you calculate the antiderivative, we see that this is equal to 1 over 256, parenthesis 3x minus 2 underneath sine of 2x due to the chain law rule, and then minus 4 times cosine 4x divided by 4, so this actually 4 cancels away, plus 3 over 2 cosine 6x divided by 6, so we actually get another cancellation here, plus cosine of 8x over 8 minus, no, not cosine, these are sines. Because we're doing antiderivative, sine, 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 and then minus sine 10x over 20. And then we get plus c. Okay, so we are slightly out of room. So let's clear this and then let's rewrite what we got. So what we had was 1 over 256 integral. Wait, not integral, we had antiderivatives. Antiderivative of 3x minus sine of 2x over 2 minus sine of 4x plus sine of 6x over 4 plus sine of 8x over 8 minus sine of 10x over 20. To make it easier for us to visualize the whole situation, let us multiply everything by least common denominator, which is 40. So if you take out factor of 1 over 40 from the whole thing, 256 times 40 equals to 10,240. So we have 1 over 10,240. And then if you multiply 40 to everything inside, we have 40 times 3, which is 120x, minus 40 over 2, which is 20 sine of 2x, minus 40 sine of 4x. And then you multiply 40 over 4 is 10 sine of 6x. 40 over 8 is plus 5 sine of 8x. And then minus 2 sine of 10x. Yeah, there was a c there. And then, of course, you have the c. So this will be the solution you will get when you do the integration of sine of 6x cosine of 4x dx. Now, let us verify that we did the right thing. So one of the ways to verify this is use a website like Wolfram Alpha. So if we go to the Wolfram Alpha site, I already did the problem. You get this, which is exactly identical to what we just got. Yeah, let us again check our answer. And 120x, we have this 1 over 10,240 out in the front, but we have 120x minus 20 times sine 2x minus 40 times sine 4x plus 10 sine 6x plus 5 sine 8x and the minus 2 sine 10x and then plus c. So we did it right. I hope the techniques that we have used in this integration would help you do other problems. If you have any questions, let me know. You can contact us at the email of cla@clacenter.com or call us at phone number 412-701-1011. So good luck. Bye.